let's get it so when the paddle misses the ball on the left side of the ball will reset. And let's make a function that resets the ball. What does it mean to reset the ball? Well, let's say it centers it on the screen. Function ball reset. We're going to take ball x, we're going to equal canvas width divided by 2. That'll give us the center horizontally. And ball y will equal canvas height, which will give us the vertical center. Now where to call it. Before we worry about getting it to connect with the paddle or not, let's just get it so anytime it touches the left wall, it resets. That'll be a reasonable test. And where does the ball touch the left side? You know, the horizontal position is the side we want, and when it goes left of 0, the left edge, that's what we're after. So in here, let us, instead of flipping the ball speed, this comment mark, which earlier we used to add notes to the code in our draw code, remember these, because code ignores anything after this comment, you can also use it to temporarily disable a line. So that's what I'm using it for here. I'm going to paste in a call to ball reset. So if the ball goes off the left side of the screen, it will run the code in the scope between the open and closed braces for ball reset. And so right there, it's going to call that and center the ball. Hopefully, that's the goal, right? Currently, it doesn't matter if it touches the paddle or not. Pop. Yeah, there we go. Now it's getting kind of stuck there because, you know, it's never changing direction. Speaking of this directional change, it'd be kind of nice if, you know, the player couldn't just get wailed on like this. So I'm going to cut that ball flip direction, paste it into part of ball reset. So as part of the ball resetting, it'll also flip its direction. Let's see if that works out. Now it should no longer just hammer the left side. If you miss, it should then alternate direction. There we go. Goes to the right. Confirms the other walls still behave as expected. And again, if it goes to the, it'll go right through the paddle right now. We're not checking that yet. But now let's do that. Okay, so where it hits this side, we want to know if it's where the paddle is as it crosses that side. Okay, well, what's the paddle's vertical position? Paddle 1y. So let's think through this. We've got if we want to know, is it below the top of the paddle? And the top of the paddle is paddle if it ball y, so if its vertical position is below paddle 1y, the top of the paddle, then it's potentially where the paddle is, but also has to be above the bottom of the paddle. And we can use double ampersands here, which refers to and also. So if it's below the top of the paddle and also it is above the bottom of the paddle. Now what's the bottom of the paddle? Well, the paddle's top is there and its height is paddle height. So we can actually write the comparison this way. I'm going to make a little quick fill this in. Ball speed x equals negative ball speed x. So if the ball is below the top of the paddle and the ball is above the bottom of the paddle, or its top plus its height, which is the coordinate of its bottom, as it is already crossing the left side, in that case, it will flip the ball's horizontal speed because it's going to bounce off that paddle. Otherwise, and that's what this else is for, the else that comes after the if that condition did not prove true, then we must be where the ball must be where the paddle isn't, in which case we should call our ball reset function. Let's save that, Control S or file save. Okay, can I reflect the ball? Reflected. Can I miss the ball? Looks like it. Now, whenever you're doing this, it's good to kind of try to test near your edges. There we go, looks like I was kind of right near one edge. See if you can miss just off of either edge. That should miss, that's good. See if you can hit it with either edge. Let's just miss just by the bottom. There we go. And then try to hit it with the top. That's going to be a good way to confirm that your math is working out right in terms of your expectations of where the center of the paddle is and where the ball is, or where the paddle is. And of course, like right now, it's ignoring the paddle's thickness. But for a quick prototype, for just getting some things working, this is totally fine. Later on, we can focus on how to deal with either paddle thickness or distance from the edge or other kind of nice polish. But this works. All right, now that we have the left side able to block the ball and let the ball pass, we have a little bit of gameplay already. Let's now build the right side paddle. Well, so what are we going to need? Let's make a paddle 2y. Do we need another paddle height for the other one? A paddle 2 height? I don't think so. We'll use the same number for both. So they should be the same height. It's fair. So here's paddle 2y, starts at 250. Here's where we draw the player paddle. I'm going to copy that, and let's say the right computer paddle. Remembering that what's in the comments means nothing to the computer. It doesn't care. It's just for us to remember as programmers what we're doing and where. I'm going to make that vertical position 2y, so it's a different variable that won't change when I adjust the mouse to move to the left side. And its horizontal position, though, should no longer be 0 because that's the left side. Right? If I keep this as is, refresh the browser, you can see there in the middle, there's like a permanent paddle there. And that's the new one that we're drawing. I could draw that in 60. Refresh. Now it's over here. That's our second paddle. How far across the screen do we want to put it to make it up against the right edge? Well, okay, we know our paddle is 10 pixels thick, right? And we know our canvas is 800 pixels wide. So we could go in and just type in its horizontal position should be about 790. 800 minus 10. Again, it's 10 thick from the front to back of the paddle. Our screen is 800 pixels wide, or our canvas area is rather. And so if I do that and refresh, you'll see there it is on the right side. But here's once again where it's kind of a nice place where if we're comfortable with using it, it'd be a perfect situation to use the canvas width minus 10. I see my code is wrapping on us. Okay, so this is a nice place for us to use this canvas width minus 10 because doing so is going to make it more readable that what we want is actually 10 pixels from the right side. It just makes more logical sense than looking at 790 and trying to remember why 790. What does that number mean? Now the other thing to look out for though is that now in 3 different places, here for the thickness of the left player's paddle, here for the thickness of the right player's paddle, and here for the use of the number to mean how far the paddle should be from the right side, those numbers need to stay in sync with one another. They need to be staying the same number. So if we change one, all 3 of them should probably change. And that's another good reason to be setting up a constant or a variable so that not only will make it more readable of what that 10 is in the code, let's call this thickness, set that to 10 up here. This will make the code easier to read because instead of seeing 10s floating around, we'll see that, okay, that label is for paddle thickness. And if I want to come up and change that number, I can change it right here and it'll fix it everywhere that needs that number. So I'm going to scroll down here to right side paddle. So there was a case of it. By the way, when it breaks line like this, it's totally harmless. Though in fact, because it's so harmless, we can manually break line to be in control of how our code lines up. I'm just going to kind of indent here. Paddle Y, that 10 is going to also be a thickness. There we go. So we're able to follow kind of where we made those changes. We made this constant of set to 10, so we can use it in place of the 10s in all 3 locations. The thickness of the left player paddle, thickness of the right player paddle, and how far the right player paddle gets drawn from the wall. And all that work, if I got it right, will look exactly the same in the game. But if I want to go back and change this and make this number 5, let's say I find those paddles too thick looking, I'll save it as 5, refresh. I still wind up with both paddles in sync for the right thickness, and the right one still being drawn flush up against the right edge. Let's put that back to 10 though. I think that was probably a more reasonable number. Now, before we worry about getting the ball to pass the right side, right now it's kind of not easy to test because the right side doesn't move at all. And if we even wrote the AI, the artificial intelligence, to control the right side for us, it'd be kind of frustrating to tell, is it passing when we think it is? So temporarily, while we work on getting the ball to cross the right side, let's switch our mouse control from controlling the left paddle to the right paddle. Go down to where our mouse input. Here we're adding every time we move the mouse, calls the event, calculates the mouse position, and sets that to the paddle 1y variable. All we're going to do is change that to 2y, since we already set up that separate paddle 2y variable earlier. Did it right up here, defaulted to 250. And because we already inserted it for where we want to draw the right computer paddle as being its position right here in code, here on the right side of that line right there. Now with just that one switch of which variable is being overwritten by the mouse position minus half the paddle height, I'm now in control of that right paddle. This will make it a lot easier to test and see if the ball is missing or hitting, which as you can see, it's clearly right now we're not doing that yet at all. So let's go and take care of that. Let's go to, it's going to look a lot like when the ball left the left side, except it's going to be for when the ball is leaving the right side. So here's the code we did for when it passes the left side. Here's how it looked when it passes the right wall. I'm in fact going to copy and paste for now the code that worked for the left side because we already debugged it, and let's look at how is it going to be different in the case for the right wall. Well, the most obvious thing, of course, right, is that we no longer are interested in its position relative to paddle 1. Paddle 1 is the other side of the screen. Here, we want to see where it is in relation to paddle 2. Is it below the top of paddle 2? And also, that's the double ampersand, is it also above the bottom of paddle 2? Was top paddle 2 plus paddle height? If so, reflect it horizontally. Otherwise, reset the ball. And what's great is because we already thought through that logic once, we just identify what are the differences of what we need next. And okay, I can reflect the ball right there. Next time I'm just going to miss it, make a point of it, stay out of its way, and it reset. Like I say, once again, let's get the test. Like, okay, can I hit it near the edge? That seems to check out. Can I hit it near the other edge? Sweet. And then I'm going to have it miss me near each edge. Miss me below. Oop, kind of got a little too close. Let me zoom in on that a little further. Yeah, so I can miss myself on either side. Now that we have the right side working for the ball to drain, let's switch that back to player 1 control of the left paddle. And now we're in business to get the right side playing automatically, which we'll do that in the next video.